I'm Devna AV, BS Electronic Systems, Week 2 lab assignment. We are to build a balanced Wheatstone bridge using 400 kilo ohm resistors. I have this circuit diagram over here. I have done the exact same thing in this circuit over here. And we are to measure the voltages at VA and VB. We have already calculated for VA and we found it to be equal to 1.2, and we have 1.18, which is equal to nearly 2. This same thing which we got. And we're going to calculate for, we have already calculated for B2, and it's equal to 1.2. And here, when we have connected, we get the same thing for B node, which is 1.18. Then we check if it's balanced. We have already done the theoretical part if it's balanced, and we found if it's balanced it will be equal to 0. So we have to check if it's true in practical form, and yes it is, because we got 0.00 volt. And next we move on with the next part of this experiment, which is to connect it into a AC voltage source, which is we here take V is equal to 2.5 plus 1 sine omega t, and we connect this over here, this one over here, and I just do this because you reset the data or something, and then we press enter, and this is connected to channel A, this is connected to ground, this is connected to channel B. Okay, how do we take this? And we connect it over here. We make it this sign. And woohoo, we got it. And it's equal to 1.17, which we got earlier, and it's great. And next we move on to the next part of this experiment, which is this circuit, which we have 1 kilo ohm resistor, two 10 kilo ohm resistors, and 100 kilo ohm resistors, and then we measure if it's balanced or not. And we're going to connect it to the voltage source of 2.5 volts and check if it's balanced using the multimeter. 0.00 volt, it's balanced, which we have already known theoretically, but now it's proven. And we measure at VA, which is equal to 0.02 volts, and next we measure at VB, which is also equal to 0.22 volts. And next we move on to the next part of this experiment. Now that's to connect it with the AC source of 2.5 plus 1 sine omega t. And then we check circuit. Woohoo, we got the same thing here too. So it means balanced Wheatstone bridge. Next, we move on to the next part, the part 2, where we have to connect a 1 kilo ohm resistor in series with R1, and another 1 kilo ohm resistors in series with R4. And then we connect this over here. Then we connect this over here. We have done, this is unbalanced Wheatstone bridge, and we have done calculations for this, and we got the R net to be equivalent to 100.5 ohms. But anyhow, we'll check it here again if it's unbalanced. Oh right, we have to connect it to the voltage source. And this is going to be 2.5 volts of the input voltage. And we got it 0.01, which implies it's not a balanced Wheatstone bridge. Hence, we can take our readings for 100.5 kilo ohms, and then do this low pass filter conversion of a Wheatstone bridge, where we take 100 kilo ohm resistance of 100.5 because it doesn't exist, and then we connect this setup to the Adlan kit. Then we take the readings of the frequency versus the output voltage using the Pixel software we have. And as you can see, the input voltage to channel A is less compared to the input voltage to channel B, which implies it's a low pass filter. And you can see the values of frequency. When it decreases, the value of the input voltage, so output voltage, increases. And here we have 10 volts, hertz, and this is the graph we get for that. And we get the value of RMS output voltage to be equal to 0.7. Then we can try another one, maybe because it's fun. And we're going to give it a 2. And it turns like this. And we have taken our readings into a table, and we have therefore built this graph. Here we have already calculated the cutoff frequency for low pass filter, and this is the circuit diagram of this circuit we have built, and it's been shown here. And this is the circuit calculations we have done. This is cutoff frequency is 159, and as you can see, within the ranges of 150 to 200, there is a break point here, and after that it keeps decreasing, which implies it's a low pass filter. We have successfully converted a Wheatstone bridge to low pass filter. Thank you.